Hello, everyone, and welcome to this lecture in the Hands on Large Language Models series. In today's lecture, we are going to cover a very important topic, and that is how to use generative models for text classification. In the previous lectures, we have focused a lot on representation models and how to use representational models such as BERT and how to use them for text classification. We saw that there are two ways in which representation models can be used for the text classification task. One way is called as the task specific model, and the second way is through creating an embedding model. In the first case, when you want to work through a task specific model, you will need to use a pre trained plus a fine tuned model. So, in this case, we used a model which was already fine tuned on the Twitter data set, and then we used this fine-tuned model itself on our data set, and that was a data set of movie reviews, and we wanted to classify whether it's a positive review and or whether it's a negative review. So this is called as the task specific model. The model which was already fine-tuned on Twitter was fine-tuned for specific tasks, so to look at the tweets and to classify whether the tweets are positive or negative. The same model was used then later for movie review analysis. The second type of representation model is a bit different. It's called as an embedding model. So it involves extracting features first. So we take the movie reviews and we convert all of the movie reviews into higher dimensional vectors. And those features which we extract from movies consist from the movie reviews consists of a lot more information about the meaning of different sentences and whether ultimately that movie review will be positive or negative. And then after the feature is extraction step, we train a traditional machine learning algorithm such as a logistic regression or even a neural network later as the classification step. And then we have the answer that whether the movie has a positive review or whether it has a negative review. So here there is no fine tuning which needs to be done, unlike the first case. And that's why the embedding method is used if we don't have the compute power to fine tune ourselves, or if we cannot find a pre trained model for doing a specific task. Right. But remember that there are two types of large language models, right? Representation models like BERT and generative models like GPT. In this lecture, we are going to look at generative models and how these type of models can be used for text classification. So first of all, let's look at the difference between the representation models and generative models on the text classification task. Let's say we have a movie review. When we pass it through a representation model, the output, the final output is a numerical value. Either it's 0, which means the movie review is positive or negative, and 1 if the movie review is positive. On the other hand, if we pass the movie review as an input to, or let's say any other sequence as an input to a generative model, the answer is usually in the format of sequence itself. So if the input sequence is what is 1 plus 1, the output is not just a number which is 2. The output is can be a sequence such as the answer is 2. Similarly, if you pass in a movie review here to the generative model, the answer can be a text such as the movie review is positive or the movie review is negative. It is not going to be 0 or 1, because fundamentally generative models generate new text, and that's why they are called as sequence to sequence models. We have an input sequence of tokens and the output is another sequence of tokens. Now our main objective is that how to take such a generative model and use it to classify the movie reviews as whether the movie review is positive or whether the movie review is negative. So let's get started with this task. All right. So the first thing to understand is that generative models are generally trained on a wide range of tasks and usually do not perform your use case directly out of the box. What does this mean? Well, if we take a generative model and we give the generative model a movie review without any context, without telling it what to do with it, the generative model literally has no idea what to exactly do with the movie review which it has given it. And so the art of guiding a generative model so that it knows what kind of answer you expect is called as prompting. And this is explained the best in the figure. Prompt engineering allows the prompts to be updated to improve the output generated by the model. So let's say the first prompt is rate the sentiment best movie ever, and then the output is given a typical sentiment rating scale. It would be rated as 5 due to its highly positive correlation connotation. I don't like this output because I want the output to be either positive or negative. Then I change my prompt. I say that what sentiment does this review have? Best movie ever. And then the answer of the generative model is that the review expresses a positive sentiment. That's good, but it's still not the answer which I want. The answer which I want is just positive or negative. And finally, then I change the prompt to is this movie review negative or positive? Best movie ever. And then the output is positive. This final step is what we want to implement in today's lecture, and we'll be doing a hands on coding exercise. The final step we want to implement is when we are given a movie, when we, let's say, have a movie review, how to construct the prompt. So there are two things which we need to figure out. Let's say if we have a set of movie reviews and we look at one review in particular, how to construct a prompt, that's the first thing which we need to figure out. And then how to convert the response which we obtain into either it should be a positive movie or it can be a negative movie review. So these are the two things which we actually need to figure out. All right. So the model which we are going to which we are going to learn today, and that will do both of these things and give us the answer as a positive movie review or a negative movie review. That model is called as the text to text transfer transformer. So it's text to text transfer transformer, which is also called as the T5 transformer. So let's start learning all about this model and what it really implements. All right. So, as the name suggests, the text to text transfer transformer takes the input in the format of a sentence or text, and the output is also in the text format. And this is called as the T5 transformer or the T5 model. This model has become very popular recently because of the wide range of tasks which this model can do. There is a specific reason why it can do a wide range of tasks, and that's the way the model has been pre-trained plus fine-tuned. So let us learn about how the pre-training and fine-tuning is done in this T5 model. The text-to-text transfer transformer is based on the original transformer architecture, which also had the encoder-decoder blocks. So similar to the original transformer, the T5 transformer also has encoder-decoder blocks, and this T5 model leverages the encoder decoder architecture. That's an important thing to note. In particular, if you look at the architecture of the T5 model, it has 12 encoder decoder blocks stacked on top of each other. So if you see, there is an input which is a sequence, and then the output is also a sequence of text. That's why it's called text to text transfer transformer. And you will see that here there are 12 encoder blocks and here there are 12 decoder blocks. So the input passes through the encoder and then the decoder and then the output is constructed, right? So the T5 architecture is similar to the original transformer model, a decoder encoder architecture. And when the T5 model was developed, there are two things to it. First is pre-training, and there is a specific way in which pre-training was done. So instead of masking individual tokens, a set of tokens were masked. So, for example, the T5 transformer was trained on a huge data set, and the way the pre-training was done was that when you look at an input, certain chunks of the input were masked, which means they were hidden from the model. Such as, for example, if the main text is LLM can be used for text generation, a form of generative AI. Now, if you have this sentence, some chunks of this sentences, such as this full chunk, such as text generation and generative AI, these full entire chunks were masked, which means that they're hidden from the T5 model. Individual tokens were not masked, sets of tokens were masked, and they were fed to the T5 model, and that's how the model was trained. So, in a way, you can think of it that the model was trained on corrupted text. So, the model was trained on corrupted text, which means that certain sections or chunks of the text were missing, and then the T5 model was pre trained to fill those chunks of text. After pre training, the second step of the T5 model implementation was fine tuning. And this is where the real magic of T5 came into the picture. Before T5, there were separate models for, let's say, language translation tasks. There were separate models for text completion tasks. There were separate models for, let's say, grammar formatting tasks. What T5 did was it made sure that in only one model, all of these tasks were actually fine tuned. And the way it made that possible is that all of the tasks were boiled down to or converted to sentence representations or text to text representations. That's where text to text, the name text to text transfer comes into the picture. So the fine tuning was not done on just one translation task, let's say, or just one text summarization task. The fine tuning was done on a wide range of tasks, such as translation. So one input in fine tuning could be translate into Dutch, and then the output can be Dutch translation. The second input will be in a completely different task, such as grammar. So check whether the grammar is fine or not. The building is tall and wide, so here it's acceptable. The third is summarize. So take this material and summarize it into a condensed or concise format. So you provide the instruction and then there is the output. And you will see that the instructions are in a wide range of tasks. The translation is here, grammar checking is here, text summarization is here. That's where the magic of T5 came into the picture. T5 really converted specific tasks into textual instructions. And that's why just one model could be used for a wide range of these tasks. So it sounds very simple and intuitive, but before T5, separate models were trained for separate tasks. And when this pre-trained plus fine-tuned model was released, it was shown to be very powerful across a wide range of different tasks. And thus, only one generative model could now be used to do all of these tasks. What researchers did later was that they extended this method of fine tuning by doing fine tuning on more than 1,000 tasks. So, a paper which is called as Scaling Instruction Fine Tuned Language Models was released. And you'll see that this paper, if I search on Google right now, this paper has around 2,600 citations. What this paper did was that it really scaled up the number of tasks which we look at during the process of fine tuning. More than 1,000 tasks were implemented here. So in the image, just showed you three tasks, right? Translation, grammar correction, and text summarization. When this paper was released, it introduced more than 1,000 tasks, and this led to a family of models which is extremely powerful. This family of model built on top of the T5 model, and they were called as Flan-T5. So the Flan-T5 models are significantly more powerful than just T5, just because of the range of tasks which they are trained on. And today, what we are going to do is that we are going to use a pre-trained and fine-tuned Flan-T5 model from the Hugging Face repository. We are going to use this model to look at movie reviews and to classify the movie reviews as positive or negative. Text classification is one more such task on which this model is fine tuned on. And we intend to do a text classification task itself. So, this seems to be the perfect fit and the right model for us to use. Now, if you have understood until this point, and if you have understood the progression from T5 to Flan T5, and how T5 and Flan T5 really did fine tuning on a wide range of tasks, and that's why they were models which are not just useful for one task but a wide range of textual tasks. Both of these models are generative models, and they represent fundamental advancements in the field of generative AI and large language models. Now, what we are going to do is that I'm going to take you through code, and I'm going to show you how we can do the text classification with generative models. So, let's jump right into code now. So, here's the Google Colab interface. The first thing to do, as we did in previous lectures, is to install libraries. So, we have to install the datasets, transformers, which are the packages provided by Hugging Face, and also sentence transformers. We don't need to install OpenAI library this time, but we'll need it for the next lecture. Once you install these libraries, you will be ready and equipped to run the code, which I'm going to demonstrate to you today. I have already installed these libraries, so here we can see that requirement has already been satisfied. All right, so the next thing which we have to do is we have to load the data set. So the data set which we are going to use is this Rotten Tomatoes. So you can search Rotten Tomatoes and Hugging Face, and you'll see that we have a data set on Hugging Face itself where we have a collection of movie reviews. That's the input text, and this is label data. So we have labels corresponding to whether the movie review is positive or whether it's negative. You'll see that in training we have around 8,500 movies. In validation we have around 1,000 movies, and in the testing data we have around 1,000 movies. So now what we are going to do here is that we are going to load the data set, and you will see that we correctly extract the training data, the validation data, and the testing data. If you look at the training, validation, and testing, you will see that these are dictionaries with keys such as features, number of rows, etc. And then we can load the encoder decoder model into the pipeline. So the model which we are going to use is Google slash Flan-T5 small. So let me show you this model on Hugging Face right now. If you search this model, you will be taken to this Flan-T5 small model. It had 300,000 downloads last month. This is a metric which I used to see whether this model is popular or not. And it's a text to text model, which is exactly what we need. You can see here text to text generation, and here if at my age you will probably have learned one lesson. Hypothesis, it's not certain how many lessons you will learn by your 30s. Does the premise entail the hypothesis? And you can click on compute over here. I'm not going to run this right now, but if you log into Hugging Face, you will be able to see how the model executes. I just do a few of these tests to understand what is the model and how it really works. For now, I've looked at this web page and I've seen that this is a text to text um, transfer model, and I need exactly this kind of model. And I'm pretty sure that of all the tasks, it's already been fine tuned on. Classification is one of those tasks. So this model is already pre-trained and fine-tuned. Most of the details are present in this section over here, but I'm not going to go through that in detail. All right, so let's go ahead and construct this pipeline. I'm going to use text-to-text generation, Google Flan T5 small. The reason I'm using small here is that there are actually medium and large Flan T5 models also. So let me show you those models. If you search Flan T5 large, yeah, there are these models also which are present on Hugging Face. I'm not sure if a medium model is present. Yeah, probably not. There is a large model which is present, and I think there is an XL or an XXL model also which is present. Let me check that. Yeah, there is an XXL model also. This is a huge model, and this takes some time to run. So I'm just starting out with a small model just to show you the results in a quick manner. If you want to go ahead and experiment with a larger model, you can feel free to change this over here to large or XL. So here you can see now that the pipeline has been created for me where the Flan-T5 small model has been loaded. And one thing which we need to do is that we need to give prompts. As I mentioned, generative models need to be guided through prompts. And what we expect as an output is that we need to look at the movie review and ask the question, is the following sentence positive or negative? That's it. And then we want an answer based on this prompt. So what we are going to do is that we are going to take the data which we have over here, and then we are going to construct another field in this dictionary, and this field is has the key T5, and in this we have the prompt. So prompt, and then we have the corresponding sentence or the corresponding review. So inside this T5 field, there will be, is the following sentence positive or negative, that particular movie review. Then the same thing in another field. Then in the same thing in another entry. So there will be entries like this in the key called T5. So when you look at each entry in the key called T5, this will be, is the following sentence positive or negative, and that particular movie review. This data is then passed through our generative model, and then the prediction will be based on this prompt. So the generative model will look at this prompt, and then it will look at each movie and classify whether the movie review is positive or negative. So here you can see that this mapping has been 100% completed for me. And then in the last step, we can do the prediction. So I'm going to use this key data set, which means that I'm going to look at my pipeline, which I've just created over here. Then I'm going to go into my testing data, because that's where we want to eventually do the final evaluation. So I'm going to look at my testing data, which has around 1000 movies. Then I'm going to look at this field called T5, and then I'm going to that will automatically mean that I will look at this prompt for all of the movie reviews in the testing data set, and then I will construct outputs. And the output is either going to be a string named positive, or the output is going to be a string named negative. So if the output string is negative, I'll print out 0. Else, if the output string is positive, I'll print out 1. So you see how we have converted the textual response into zeros or ones. We first constructed a prompt so that the output is either the string positive or the string negative. And then we assign that if the string is positive, the result should be 1. If the string is negative, the result should be 0. That is how generative models can be used for classification, for numerical classification. Earlier, it was very non intuitive for me that generative models can be used for numerical classification. But there are some smart ways, like what I've showed you, through which textual data can be converted into numerical outputs like 0 and 1. So this is the prediction script. What it does is that it goes through the testing data. It looks at all the movie reviews in the testing data. It applies this prompt to those movies, and then the output is produced. And then, as we did in the previous examples, we can print out the classification report. We can check the accuracy. So the accuracy is 0.84, which means that 84% of the time, our classification, our model classification for the testing movie reviews is correct, and it matches the actual data. Remember, we have a label data set here. So we have the true label for this, for the testing data. And now we are comparing whether our generative model predictions matches the true labels or not, and we can see that 84% of the time it's matching, which means we are doing an awesome job with the Flan-T5, even the small model. You can try the large and the Excel model and check if the accuracy improves or not. Second thing to note is that the F1 score is quite high, 0.84, and it's comparable for the negative reviews and positive reviews. That's very good. Generally, an F1 score of zero point 0.8 or above is good, and generally it's also good if the F1 score for one class is not too different than the F1 score for the other class. The precision and the recall values for both the positive review and the negative review are also pretty good. Both of them are similar to each other, and they are both higher than 0.82. So here we can see that by all objective metrics, our performance on the testing data set is actually very good. And this is awesome, because earlier we had used a generative model for text classification, and now we had used a representation model for text classification, and now today we have used T5. So in the previous lecture we learned about how to take a Roberta base model, and how to later use an advanced fine-tuned version of it. And in today's lecture, we learnt about T5 and how to use an advanced version of T5, which is the Flan-T5, right? So this actually brings us to the end of today's lecture, where we saw how to use a generative model, Flan-T5, for text classification on a movie reviews dataset. Through these exercises, what I want to demonstrate to you is that large language models are a big field, and several of these large language models can actually be used to do the same task. If you remember, in the previous lecture, we looked at generating embeddings, right? And we looked at a sentence transformer for creating these embeddings, which was based on, um, I think it was based on the sentence transformer in Hugging Face itself. So let me actually see where on what the sentence transformer was based on. So this is the previous code, and here you will see, yeah. So we use this sentence transformer from Hugging Face to create the embeddings itself. And in the method previous to that, we took a Roberta base model, and then we used a Twitter Roberta based sentiment model, which is already fine tuned on top of that. So in the lecture before the embedding lecture, we looked at this task specific model, in which we started from a Roberta based model, and then we used a fine tuned model on top of that. So Roberta can be used as a representation model, and today we looked at T5 and Flan-T5, which are generative models which can be used for the same task of text classification. The reason I'm showing you all of these methods is that this playlist or this lecture series is hands on large language models, and I want to show you that in the field of natural language processing, uh, representation models and generative models both can be used to perform tasks such as text classification. In the next lecture, we are going to look at using ChatGPT OpenAI API to do this similar task of text classification. So then we would have learnt of four methods. Two methods in the representation models, the task specific method and the embedding model method. In the generative model, we learnt about Flan-T5, and in the next section we'll learn how to use ChatGPT and OpenAI API to for the text classification task. Thank you so much everyone. I look forward to seeing you in the next lecture.